Hello, hello, hello there. How are you? You like the first talk? I didn't hear you. Are you like the first talk? Yeah. Okay, you're still sleeping after the first talk. Perfect. I want one thing. I am asking you one favor. Can I have the biggest yeah that all the people in the alpha room can listen to our yeah at my free? 1, 2, 3. Yeah! Perfect. Thank you, thank you, thank you. So now I'm going to I'm going to introduce Graziano Casto. This is his first talk ever. So no pressure at all. He is a technical product expert. I don't know of what. Expert of what? It's fine. At Mia Platform, and his talk is about practical policy as code with OPA and managed sidecar container. And we are looking at him. He says to me, he is not so good in orienteering. In fact, we found, because we are looking at him for the talk, and he's still looking for the open bar of yesterday, and still looking today, but we have found him, and now he's here, unfortunately. So, for his first talk, a big round of applause for Graziano. The stage is yours.
Thank you very much, Davide. Good morning, guys, and buongiorno a tutti for my Italian talk, my Italian folks, and welcome to my session. Today, we are going to see different approach to policy management and exploring the world of policy as code. And since we are here to talk about open source project, we will do it exploring to awesome open source project, Open Policy Agent and Rönd. Who am I? My name is Graziano. I know it is not the easiest Italian name. You can call me Graz, or if you catch me around the conference, hey, you is enough. And I work in the developer relation team at Mia Platform. Before that, I was a product owner, and before I was a software developer, as I think many of you are. Mia Platform is a product company which brings to the market an internal developer platform builder. And this product helps our customer to build their own EDP to enhance developer experience and increase time to market. Going on, what we are going to see today. The presentation is divided in 3 main parts. The first one is, I know, a little bit boring for those who is already familiar with the topic, but I need to give some definition of what is a policy, what is policy as code means, to have the right context to go on with the other parts of the presentation. Next, we explore what is at its core policy decoupling, how we can implement a policy decoupling approach, and which tool can we use to do it. And last but not least, we will see a practical approach to apply policy decoupling to a simple example of API authorization. Okay, what I talk about when I talk about policy as code. Before start, how many of you listen about policy as code or hear these terms before? Raise an hand. Okay, it's like 50% of the people here. Before defining what is policy as code, let me say what is as its core a policy. When we think about policy, we are going to think about authorization, and that's true. But at its core, a policy is simply a set of rules which govern the behavior, regulate the behavior of a system, in our case, a software system. How it's regulated? Simply by defining how and what happen to say that this system is valid or not. To be clear, we are going to talk about authorization, and policy are strictly related to authorization. Authorization, in fact, is a special kind of policy, but to talk about authorization, we are going to be already authenticated. So authentication and policy are not related. To do what we will do with the practical part, we are already authenticated. So authentication is not the topic of this presentation. Okay, what is policy as code? Let's try to give a definition standing on the name. Policy as code is an approach to policy management in which policies are defined, updated, and enforced using code. Okay, I know, it's obvious, but it's a really powerful definition, because using code to define something allows us to get some benefits that we will see. And the first one, in a standard approach to define our policies, we define and enforce them directly inside the system that must be enforced. So imagine a context in which you have many different services, and each service is written with a different programming language based on the best language that suits this situation. Writing the policies inside the service means that you have your policy written in many programming language. So use such an approach, you centralize the policy in another repository, you write the policies with only one programming language, and so you gain much more visibility over your policies, and you can give to all relevant stakeholders the visibility over the policies just if they know one programming language. So they are not forced to learn Go, JavaScript, and others. They need to know this one declarative programming language to know what exactly happened in their systems. Going on, we will see this benefit with many other as code approach. Just think to ISC, infrastructure as code. Having something defined as code allows us to automate this operation. What does it mean? In our context, we define as code policies, so we can automate the policy enforcement. And so we can avoid any risk of mistakes due to manual operation. And last but not least, we all are developers, we all love test, and I think that all of us have a high percentage of test coverage in our code base, right? And so we can also test our policies just using the tools we have to automate this test. We will see later the programming language which can be used to define policies, and it's out-of-the-box framework to test them. Okay, move now to the core of the policy as code. Policy as code allows us to implement a policy decoupling approach. What does it mean, policy decoupling? At its core, simply means the separation of the policy definition, which will be in our repository, written in this famous language that we will see later its name, from the policy enforcement. See that that example on the screen. This is a generic example of a policy decoupling application. In a standard approach, you have this generic service, which could be an API server, could be a streaming platform, Kafka, an API gateway, what you want. Requests arrive to the service enforces the policy itself in a standard approach because it owns their own policies. With this approach, requests arrive to the service redirects the request to a generic policy agent, which is him allowed to get policies from our code base and enforce them over the request it receives. Just to be clear, you see also data. I know that it is not maybe the most beautiful best practice, but just to let you know how powerful this approach is, just think that with defining policies as code, using this approach, you can also read data from a database and use them to evaluate the request you received. Okay, we see what policy decoupling is, how we can implement it. We have to create from scratch our policy agent, which is the policy programming language, how we can define our policies. Exists a tool, and the answer is obviously yes, and this tool is Open Policy Agent. Open Policy Agent, to keep it short, I will call it OPA, is an open source project, is a CNCF graduated project, and basically it provides us two things. The programming language defines our policies, which is called Rigo, and is a high-level declarative language, and the policy agent, which take our policies from the code base and enforce them over our requests. Okay, this is the how Open Policy Agent works. You will see the diagrams on the screen that is the same as the two slides before, but we have services that are a list of services that are natively integrated with Open Policy Agent. You can see Envoy, so you can use Open Policy Agent to regulate the behavior of a API gateway. You can see Kafka, and you can see it here, but you can use Open Policy Agent also to regulate the behavior of your Kubernetes cluster, for example. Using, I hope I'm not wrong, the Open Policy Agent gatekeeper, you, for example, perform ingress validation on your Kubernetes cluster. So it is not a project that is limited to API authorization. This is a simple. This is how a simple Rigo policy look like. I don't go deep explain how it works because we will see later in the example. And okay, we have Open Policy Agent. We know the theory behind policy decoupling. We could start implement our service that is enforced using Open Policy Agent. Yes, we could. But we want to do it in a way that is capable to scale in a context where we could have thousands of users. And to do so, we use one of the authentication approach already exists. For example, role-based access control, which is an authentication mechanism that introduce the concept of role to regulate the access of an individual to a specific resource. Or attribute-based access control, which is another authentication mechanism on top of our back that adds the concept of attributes. To do so, in Mia platform, we create this project, Rönd, that use the Open Policy Agent capabilities. So Rönd use Open Policy Agent as a policy agent and use Rönd to define policies, but apply the Kubernetes sidecar pattern, and it allows us to do minimal code changes to our project to implement such an approach. And Rönd also adds as a building block the concept of role, permission, a user group, and allow us to implement a ready-to-use solution, a airbag solution. As I said before, due to its soul as sidecar container, Rönd can be used as sidecar container, obviously, so without adding any single point of failure. What means that Rönd can be used as sidecar container? This means that each service who need to be enforced can host inside its pod a Rönd container that intercepts all the requests directed to the service, enforce our policy over this request, and only the accepted request arrive to the service. If you prefer, obviously, you can use Rönd as a standalone service, and so you have to adapt your service to redirect the traffic to Rönd. Rönd evaluate them, and then the response goes back to the service, if it is accepted. Okay, let's see a real-world example of Rönd usage. Imagine we are in a context of a store supply chain. We have an API to retrieve the info of the store, okay? This API returns the opening hour of the stores, so we don't need to authenticate it. Next, we need an API to push the receipts from the store to a central cloud, an ERP system, for example. And to do so, we have this post call to /receipts endpoint. This time is obviously authenticated call, authenticated request, and we introduce two roles, a salesman and a store manager. We want that the store manager can push the receipts for any store in the chain. Salesman, instead, can push receipts only for the store they are allowed to. Last, we have, as we can push the receipts, we have to retrieve the receipts from our ERP system. And to do so, we have these two roles that salesman and store manager can get all the receipts available, regardless the store they are assigned to. But store manager can access the entire document of the receipt, and the salesman can access the document of the receipt without the customer and payments information. Okay. Before start configuring Rönd and write our policy, let's understand how we get the information we need to authenticate the user, to authorize the user, sorry. This is how a simple request to our service store info looks like in a HTTP client. Pay attention to the either property in the option object. We have the authorization property. It's a string. It's basically a JWT token, JSON Web Token, and decoding this JSON Web Token, we can get something like that. That is a JSON who say us who is the user who is performing the request, in this case a salesman, and which store are assigned to it. Rönd needs to be configured. To be honest, you can use your OpenAPI specification to say which routes Rönd have to enforce, but This time we configure Rönd manually. And to configure Rönd, we need a JSON file. This JSON file have the list of all the routes Rönd need to intercept and all the routes Rönd have to enforce. How is structured? We have our store info route, and inside each method allowed to this route, we have an xRound property with a request flow object in which we define the name of the RIGO policy we will use to enforce this route for the specific HTTP method. Okay. For the store info route, we said that it is not an authenticated route, so we allow all requests to pass. In fact, our allow all policy simply return true. Moving on to the second example, in which we will see how to enforce policies over our post receipt. We said that store manager can push receipts all over the chain, and the salesman can push receipts only for the assigned stores. This is how a call to receipts route look like. Pay attention to the header and the data object, which is the body of our post request. And first of all, we need to evaluate the role of the user who performed this request. To do so, we write a simple RIGO function that accepts as argument a string. We will use this string to compare it with the actual role of the user. Then this function gets the authorization object inside the headers of the request and decode the JWT token. Decoding the JWT token, we get this JSON, as we see before. From this JSON, we need just the string salesman, the property role. So we get the role property and compare with the required role we received as argument. Okay, and that's the first condition we have to evaluate. Then we have to check that this receipt we are trying to push, in this case, we are trying to push a receipt to the store with ID 1, is a store assigned is a store that is contained in the array of assigned store to the user. To do so, we write another RIGO function. We call it user belong to store that accepts a ID of the store which is required. This ID, spoiler, is the ID we can get from the body request of the request. We will see later how. As before, we encode our authorization property of the header. We get the same JSON as before, and this time we get the stores array. With the stores array, we iterate over the stores assigned to the user, and then compare each store assigned to the user with the required store we want to authorize. Okay, now configure Rönd to protect this route. How we can do it? Add the receipt route to the file to the configuration file. Add the post method, and inside the xRound property, as request flow, define the policy name allow create new user. This policy name just use our defined function and first check if the user is a store manager. If the user is a store manager, it accepts this request without any further check. If it's not, get the store from the request body with the input parsed body.store and use it as argument of the user belong to store function to evaluate if this user is contained in the user assigned role, is in the user assigned store. If it is, then accept this request, and the post logic is performed. Last, we have the get receipt route, and this time we want to make sure that salesmen get only the fields from the receipt without the customer data and the payments data. This is how it look like this get call, and this is what we get if we don't enforce any rule to this route. This is correct for store manager, but as we say before, we have to remove payments and customer if the user who performed this request is a store manager. How we can do it? In the receipt object we configured before, add the get method, and this time in Rönd property we add request flow just to authorize the request, and the response flow to filter the response before returning it to the client. The allow access receipt just check using the previous function if the user is a store manager or a salesman. If not, the user is the request is denied. The protect receipt info get the response before returning it to the client, and if the user is a store manager, return it without any change. If the user is a salesman, iterate over each document in the resource, and simply with a object.remove remove the customer object, the payments array, and then return it to our salesman. Okay, that's all. Let me do a recap of what we see. We saw what is policy as code, what means a policy, and how we can implement this different approach to policy management. We see Open Policy Agent as a powerful tool that allows us to implement it, and finally, how to implement our airbag solution using Rönd without any changes or minimal changes to our code base. That's all. If you have any question, feel free to ask me, and if you want to leave me some feedback, just scan the QR code or catch me around the conference. Thank you very much.
Thank you, Graziano. Thank you. How's it? It's fine. Your first talk, fine?
Fine, fine, fine.
You like it? It's first talk. A big fan of course, because it's first talk. I know the pressure when you have to do your first talk. I've made my first talk last year, so I'm great to have him the first talk here at Open Source Day. But now it's time for a Q&A. So if someone has a question, perfect. Another jogging time.
Don't kill me, please.
Okay. So what is the difference between Rönd and Istio? I mean, it seems that they do more or less the same stuff, right?
Okay, I don't know exactly what perform Istio, so I can respond to this question. But if you want, I can report this question to our R&D teams, and then we can respond.
Okay.
We can answer, sorry.
Thank you.
Using this approach and moving out the policies to a central point, how do you manage the code base? You totally remove any authorization logic, or you keep some of them coupled? And did you made any comparison about resource consumption? Because in this case, we have a sidecar for any pod. Instead, you are choosing the service approach. In the other side, we have just the code base that is running on its own.
Okay, it's your choice to to remove all authorization logic from your services and keep them in a central repository, or you can have a balance between something that you know that is ever this and keep them in your service logic, or move the variable part to the central repository to have visibility over it. And for the second part of the question is the same. It's for sure you have a more consumption of resources using a sidecar approach, but you have to compare it to the effort you have to change each time a policy when it changes.
Other questions?
Grazie.
Here, Eduardo.
Just out of curiosity, if you know it, since usually the configuration language for the cloud is YAML, do you know how they decided to use JSON instead?
I don't know why, but if I have to guess it, because you can get the Rönd configuration from the OpenAPI specification, and if
Okay.
I'm not wrong, they are in JSON. So
Yeah.
to maintain this comparison, we use just one configuration file format.
Makes sense. Thank you.
Other questions? You have a question for yourself?
No.
Perfect. So, perfect. As your first talk is here at Open Source Day 2024, I acknowledge you with this trophy, with Shodi. Just
Thank you very
remember
much.
your first talk.
Thank you very much.
Thank you. Thank you.
Grazie a
Graziano.
tutti.